So today you heard a lot about renewable energies, electromobiles, and a lot of other very interesting business models for the future. But most of them will not work if the intelligence grid is not coming to the electricity grid. Because without intelligence inside the networks, you will not be able to manage the things. One very simple example is you heard about the Tesla. I think he would like to hear that you have 1 million Teslas in 2020. But if you have 1 million Teslas in 2020 in the electricity grids, and they come, let's say, to the load station at 5 or 6 in the evening, and there is no management for the load, you will have a big issue. It can be, let's say, a perfect situation if the wind is blowing on the North Sea, but if it's not blowing, you have a big problem. And so you need really a smart grid which is able to manage all these new applications. You heard a lot about renewables today. I will not repeat it again, but we have a dramatic increase in the renewable energies within the next 10 to 20 years. But this is not a problem only for the future. It's even today a problem for the network operators. In the south of Germany, a company like E.ON is connecting about 300 solar plants a week. And that's a big problem now for them to operate and to keep voltage in the networks. And so they have to do investments or to make the network smarter and to use the options which they have in the electricity network. Another problem is the fluctuation in the energy of renewable production. When you are going here to the wind capacity, you see the fluctuations even on the daily level, and the daily fluctuation range sometimes from 3 to 14,000 megawatts. And that's a big, big story for the network operating things. We see even today in the market negative prices on the electricity stock exchange market. And of course, that's an economical result of a situation that the networks are not managed in a way like they should be managed in the future. And by this, we see inside the network really a paradigm change towards a network which was in the past a top-down network, energy production in big plants coming down to the customer, a customer without having any communication, who was not partner in this network, is simply someone who's buying energy. And it's going towards a decentralized energy structure. You have, of course, real-time and the demand for real-time communication and interaction between the clients, between the generations and the consumption. And by this, the whole world of information and communication technology will become a key part of the energy of the future. The future energy without, let's say, a central role of communications will not be possible. So the world of energy and the world of communication are in a word merging, and that's the story of the smart grids in the future. A lot of the activities which you heard today in the newspapers are about metering technologies, to have a smart meter with the private households. And originally, the technology started with narrow-banded communications only for the meters. But there is unfortunately no business model for metering only. That's a big problem today. You see even in the regulation, and you see in the political and the discussions of the utilities. You have to find a solution that you have more applications on your network, on your information and communication technology. So you need a structure where you are able to have a lot of additional application and products on the network which are part of a smart grid. It starts with the metering. It goes through real-time information for the clients. It goes to demand response measurements. It goes to electromobility, public lighting, ripple control, all the applications which utilities partly have today in their network operation, but also things they will have in the future. And the key point is here to have a scalable communication infrastructure. And this communication infrastructure will be very similar to the one you have in telecommunications. It will be a broadband communication. It will be a standard-based IP communication, and that's the future of communications in the energy networks. And that's where we are as a company. The Power Plus Communication is coming from. We are a provider of information and communication technology for smart grids. We are using the electricity grids itself to do the communications. We are going for power line communication technology. Actually, all over Europe, the power line technology is the favorite solution for ICT in the smart grids. A big discussion today is how performant it must be, and we are going for broadband communication performance here. And this means we have actually a communication solution in the market which is IP-based real-time communication on smart grids and smart metering. We're a German-based AG with about 41 employees. The shareholders, one of our investments is Climate Change Capital, the management, the key employees. We are mainly in Europe and in the Middle East. We are having today cooperation agreements with a couple of the big players in this market, starting from Cisco, IBM, GE, Nexans, all the meter vendors. And you see even today from this map that we have become, in the past 24 months, one of the key leaders in this market in Europe. In Germany, we are in business today more or less with all the leading utilities. We are in Europe, we are having business in France with EDF, all over in Europe. Utilities are now looking for technology which fits to their requirements. We also selected for the Germany Energy Project as the key beacon project for ICT in the energy industry, and we passed about 300,000 households now with the technology. When we are talking about communication in smart grids, you have to split away in the communication which you have on the low voltage level, means where the households are connected, and the medium voltage, which is a connection between the stations. On the low voltage side, there is a meshed solution which is communicating with all gateways which are connecting the households, with street lighting applications, with electromobility and other things. On the medium voltage side, we have today even a big business, not only driven by regulation, mainly driven by operational requirements coming today from renewable energies, because the share of renewable decentralized plants in some regions in Europe increased dramatically, and the utilities more and more needs communication and operation systems inside the stations to manage this situation. When you go to the cost side, the requirements are always a low cost side, and you see today that the cost of smart metering in the future and smart grids are not that expensive. It's about 2-3 euro a month, which you have to pay for this side. On the other side, for, let's say, traditional telecommunication solutions like DSL, it's only a small, let's say, sales per month. 2 to 3 euros a month is nothing compared to the telecommunication earnings, which are 30, 40, 50 euros. So you need a very cheap solution. Actually, it seemed to be that the solutions of Powerline are the preferred one, and to go for broadband is the only one actually which is scalable and which is real-time based. The energy project, the German flagship project for this area smart grid, you see here that all the clients today in such a project are directly connected to the energy network. So you connect on the one side, let's say the meters, you connect also the decentralized plants. For example, in the model Mannheim, where we are providing the information platform, we have about 1,000 decentralized plants which are connected to the network. So that's a big amount for a town, but all are small plants, and you have to measure them, you have to operate them, and you have to get the information from it. The future will be that each house will have in such a smart grid a kind of a gateway, a house IP connection. That's also the result of the actual monitoring report of the German regulator, who tells let's say the ministry that you have to find a solution, bringing to the networks solutions that only the house has a connection, not only the people in the house, but also the house as such. And this is a kind of a house gateway, a house IP connection, where the intelligence can be part of the intelligence will be centralized, and this is a gateway which is also helping then the end customers to improve their energy efficiency. You see here in one example also the influence you can have on the load profile of the end customers. You see here the load profile, the red one on top, which is the base profile. And in the project, we are having, let's say, dynamic tariffs towards the households, and so offering them really cost reduction in their daily operation. And they can adjust their demand to, let's say, the cost side, and they can really have an influence on the load profile. And you see here that you really can have a load shift and use this load shift then for, let's say, improving the whole operation of the network and the procurement process in the energy network. Another part is here in Cologne and Rheinenergie. The end customers are getting real-time information. Really, they see when they switch on and off the light, so they can get the real-time information. to see how, let's say, the consumption is changing and things are changing. And all this is in real time. It's not the information from yesterday, it's the actual information the end customers get. The future structure, as I said, will be that there is a gateway towards the house. The gateway means that you have, on the one side, the connection to all the technical applications inside the house, but you will have also, on the gateway, some applications. Applications for metering, applications for e-home, applications for demand response, maybe security products. So there will be a wide range of products which are far beyond the pure metering. Yeah, that's a small entrance to, let's say, the smart grid. And let's say a very core point today is that in the international regulation, a lot of drivers are now, which are, let's say, pushing the development of the smart grids into reality. In 2020 latest, we will have 80% penetration of smart meters by law in Europe. So this means about 400 million meters which have to be replaced within the next 10 years. So that's a big business, but also a big challenge. So thank you.